Again, welcome to today's webinar, Log Analytics with Amazon Elasticsearch Service. Our presenter today is John Handler. John is a solutions architect working closely with the AWS Search Service team and providing help and guidance to a broad range of customers who have search workloads they want to move to the cloud. Prior to joining AWS, John's career as a software developer included 4 years of coding a large-scale e-commerce search engine. John holds a Bachelor of Arts from the University of Pennsylvania and a Master of Science and a PhD in Computer Science and Artificial Intelligence from Northwestern University. Today with us we also have Carl Meadows, who will be our webinar moderator today, answering your questions through the Q&A panel. John, welcome to the session. The floor is yours.
Thanks, Jerry, and thanks everybody for joining today. Really appreciate your participation and looking forward to the session. So in laying out what we're going to do today, the first thing we're going to do is we're going to dive right into a demo and have a look at Elasticsearch in action, if you will, on AWS to see the kinds of things that you can do with Elasticsearch and with Kibana. We'll then dive into the underlying technology so that you can understand how Elasticsearch accomplishes the on-screen and visualizations and analytics that it does. We'll cover aggregations, which are really foundation of the analytics that Elasticsearch provides. And then we'll talk about the Amazon Elasticsearch service and give you some background and feel for what the service provides and how it makes it easy to operate and manage an Elasticsearch cluster in the AWS cloud. At the end of the presentation, we'll have time for Q&A, so we will be answering questions in real time, but also at the end, we'll have an opportunity to answer questions out loud. So again, diving into the demo, we're going to start with AWS CloudTrail. And if you're not familiar with CloudTrail, CloudTrail logs calls that you make to various AWS services as you manage and change your resources. So different services like EC2 or Elasticsearch service log out the operations that you're performing as you perform them in an administrative capacity. And this is a really nice service that we provide that allows you to go back and audit and figure out what's going on with your AWS resources. Now, I have on screen a quick screenshot from the CloudTrail console. And what you can see here is that, yes, indeed, all of that information is there, but my ability to drill into it and my ability to bring up different interactions that I've had with my services is somewhat limited. I'm limited to a scrolling list. I have some ability to dive in by event names, but the information is not exactly in its most accessible format. Elasticsearch is a technology that's been on the scene since about 2009, so going on about 7 years. And Elasticsearch is a search engine. Search engine, is something that you would encounter, for instance, for web search or an e-commerce site where you would think of searching for various items that you want to purchase. Elasticsearch similarly can take in data and function as a search engine. However, it is somewhat specialized to handle streaming data sources like log files. And Kibana is a web UI, also an open source project, that allows you to visualize the data inside an Elasticsearch cluster. And we're going to see some really great examples of that. Just to talk through the architecture, the demo at a high level, what we're going to do, I have my AWS user on the left side interacting with various AWS resources through the API, the SDK, CLI, what have you. And as the user interacts with those AWS resources, those interactions are logged to CloudTrail. We're going to set it up to send the CloudTrail logs into Amazon CloudWatch logs. It's a very simple setup. And then from CloudWatch logs, we'll stream them to Amazon Elasticsearch service where we'll be able to visualize them with Kibana. And again, you'll see this is all simple to accomplish through the console. Just to get a feel for, again, what is going on underneath the covers and what is the data that we're dealing with, this is an example of a single CloudTrail log line. And you can see here we have a number of different fields, things like the event version, the user identity, which is further subdivided up into other information about that user, a time the event occurred, what was the source of the event, which service, what was the name of the call that was made, some timing information, IP information. Also, all of this information is bundled up as a single CloudWatch log line. So as we go to visualize it, these are the pieces of data that we can use to build visualizations. And again, we'll see that in action right now. Let me just get changed over to my screen. So we're going to start out in the CloudTrail console. And in the CloudTrail console, I can create what's called a trail. That trail will receive the log lines that we saw and store them eventually in S3. This is the typical path. So if I just quick do webinar demo, I'll just name it. I can apply my trail to all the regions, so I can get all of the data from every region or different regions. And then I can either create a new bucket or pick a bucket, but in this case I'll create a demo bucket, and hopefully that's not taken, and I can create that. At this point you can see here's my handler webinar demo. Data is now going to flow into that bucket eventually, but through this trail. If I click on my trail, I'm able to go to a section in the description information for CloudWatch logs. Here I can set configure, and I can send it to a CloudWatch logs group. So let's call it the handler webinar demo log group, and continue. This will send me to the AWS Identity and Access Management IAM console. What's needed here is simply to give CloudTrail permission to write to the CloudWatch logs group. So we wait until that gets set up, and this takes just a few seconds. Oh, there's a problem. Awesome, it's a demo. We're going to just jump forward to the CloudWatch Management Console because I have already set up this streaming, and rather than try to debug in real time here, I'm just going to show you an existing one. So I have here, where is it? I have here my data flowing into CloudTrail and CloudWatch logs, sorry. And we can look here and see that indeed, as data comes in, I'm getting it as these log lines, and here it is in CloudWatch logs, and it's again not the simplest to view or to understand what's going on at a kind of higher level. So what I can also do here is I can set up. I'm going to show you the setup, and this would be the same action I would take with my demo that I was trying to set up from CloudTrail. So I can simply select one of my log groups and stream it to my Elasticsearch service. And CloudWatch logs will then ask me for an Elasticsearch service. I am, again, I need to go through IAM to enable CloudWatch logs, in this case, to write to Elasticsearch service. And again, I'm just going to accept the defaults there, and I'm good to go. So if I go over to my Elasticsearch service, what I'll see here is, and I have a, again, setup version. So this Elasticsearch service domain is accepting, again, CloudTrail information from all of the regions. I have a number of indices here. These are split out by day, and you can see I have quite a bit of data in this. I'm then going to flip over to the Kibana dashboard and show you the kinds of things that you can visualize and the kind of analytics that you can do. So I'm looking at a period over the last 4 hours. I have some just bare bones metrics at the top. So I have a count of how many events occurred that were reported by CloudTrail over the last 4 hours. And then I have a count of error codes. So I can, again, looking at the logs, one of the fields specified as error code, I can do a simple count on that field to see how many have values. And then I can do a count of the users who have accessed or who have been reported in any of the CloudTrail events. I can also get a simple histogram, a simple bar graph that shows me the distribution of those calls across time. And then I can even break it out in terms of the services that are used. So I can histogram by which service. So logs.amazon.com, ec2.amazon.com, S3. This gives me a nice view of what services are being used across this 4-hour time period. And I can even dig in deeper than that. I have a more complicated chart here that looks at the user identity. So in this case, this is my root account. And then within my root account, what region did I call? So in this case, most of my calls went to the US West 2 region. And within US West 2, I can even further subdivide into different events. So terminate instances, describe alarms, describe delivery stream, etc. Create tags. All of this allows me, again, to get a really nice granular view of overall which accounts were doing what to which services. I can then split it out as well to see which are the services that were called across time. So here I have a nice graph that shows me, logs. This is my calls that were made to the log service, S3. Here's my EC2 calls, RDS, etc. So this gives me sort of a sliced up view based on time of when I was calling things. And even I can drill into particular services. I can look at what happened in EC2. I can look at what happened in Elasticsearch service, in auto-scaling, etc. At the bottom, there's also a table view that lets me pull out what are the error messages that I've gotten. So if I were going to go in and try to figure out what's going on with my resources, why am I getting errors, I can then use Elasticsearch as it's a search engine to pull out those errors and dig into what exactly happened around those errors. So this is, again, Kibana that we're looking at, supported by Elasticsearch, in this case the Elasticsearch service, and it allows us to do this kind of ad hoc querying and analytics across the CloudTrail data in a way that's much more intuitive than a big long list of calls. So I'm going to switch back to my slides, and we're going to talk about how it is that this kind of visualization gets onto the screen. So we covered, sorry, we're having a little bit of technical difficulty here. I'm not having anything on my screen.
All right, so John, looks like may have a little internet connection issue there for you. We could have you rejoin and reset the browser for you.
Sure, we can do that, or we could make Carl the presenter if he is. We can advance the slides from his machine.
Yep, Carl's all ready to go. Carl, you can advance the slides.
Okay, great. So we've seen, one of the use cases, and looking at how people use Elasticsearch, the most common use case that we have for the service is really this kind of log analytics use case. We see maybe 60–70% of our customers who are doing some kind of log analytics that's very similar to what I did with different kinds of logs. And some of these logs are syslog or Apache web logs or CloudTrail VPC flow logs. All of these different kind of logs provide you the ability to make visualizations and drill in and figure out exactly what's going on underlying. A closely related use case that we have is more of a batch analytics use case where customers are using clickstreams to look at how their users are using their applications, whether their applications are successfully engaging their users and figuring out what's going on underneath. The final use case that we have is the full text use case. And just to emphasize that Elasticsearch does provide full text. All right, so let's look at Elasticsearch, the technology underlying, and just get some understanding of how does Elasticsearch provide support for this kind of analytics. So the first comparison to make is to make the analogy from Elasticsearch to a database. If you're familiar with database technology, this will help you kind of get a grasp on what's going on in Elasticsearch. So databases are organized at a top level into a database. In Elasticsearch, we call that a cluster. Then within the database, you have some number of tables, and within Elasticsearch, you have a number of indices that function like tables. Within a database, you have a row, which is essentially one data point within your database. For Elasticsearch, this is a document. In the database, then you have columns. These are typed cells, basically, where you put values. In Elasticsearch, you have fields, which are typed and which take values as well. So at the core, you again have documents that are coming and going. Thinking about the CloudTrail log line that we saw, each log line would be a single document within an Elasticsearch cluster. With the query methodology is a little bit different. In a database, we use SQL, where in a search engine, we have search queries that are formatted either as JSON or there's a simpler version in Elasticsearch that you can use as well. So the document is the core entity, and just looking back at that CloudTrail example, again, we have a number of fields here, like event version, event time, event source, etc. These are all put together into a single document that gets sent into the search engine. Within the search engine and at its core, Elasticsearch is based on Lucene for doing text analysis, indexing, and searching. Lucene is a Java library that has two basic functions. One is an index writer that takes a document, parses up the fields, separates them out into individual indexes, and writes those indexes to disk. And within that index, what we have is essentially within each field, we would have each of the words that occurs, and this depends on the type, and it could be a double, it could be a date, etc. But the idea is that we have a breakdown of each term that occurred, and then pointing to a list, which is called the postings list, of all of the documents where that occurred. Our index searcher then can go and with terms that the query contains, pull out those lists and perform the logic on to get the match. So a query comes in. Again, we have an index lookup step where each of those words is looked up within its respective field index. We apply the query logic. So if I have multiple terms, I would do the intersection of all of those terms. I have an OR, I would do the union of all of those posting lists. We apply post filtering, and then we get a set of matches. On that set of matches, we then score each of those matches and compute our aggregations on top of them and return that as our sorted result set. So this is a really quick overview. How does query processing work? Now, within search engines, and specifically within Elasticsearch, what backs the visualizations that we saw is something called aggregations. An aggregation is, to understand aggregations, we start out with faceting. So if I'm on an e-commerce site and I type something like shirt, I'll often see on the left of the screen a list of something like brands. So in this case, we have Carhartt, Russell Athletic, Dickies, Ralph Lauren, etc. That would tell me within the set of matching documents how many times did that value occur in the brand field. It's a very simple way to count values within particular fields. So this is the basis of what grew into, or has grown into and continues to grow into, aggregations in Elasticsearch. So in Elasticsearch, we generalize the concept of a facet and say, okay, well, we have buckets, which is some collection of documents meeting some criterion, and then a set of metrics that we can calculate on those buckets. In this case, we have a simple aggregation where our bucket is time. So we take all of our documents and we compute buckets based on time slices to put those documents into. Our metric is count, so what we do is we count all of the items in each of those buckets, and that gives us a list of, essentially for each time slice, how many of those log lines fell into that bucket. So that's the simplest kind of aggregation that you can do. Now we also saw this more complex aggregation that looked at the account and then the region and then the call. And this is supported by sub-bucketing. So you can nest aggregations within aggregations. In this case, we start at the center with the ARN bucket, so that's the user identity, and then we bucket everything that's already in that bucket into different regions, and then for each region we bucket into event names. And then we perform the count metric to tell us how many items fall within these buckets of buckets of buckets. So this, again, is what backs these more complicated visualizations and ability to look at what's in the data. And there are a number of different kinds of aggregations and a number of different metrics that you can compute on them. So we don't only have the histogram or date histogram, those are the time slices or regular slices. We can also do terms aggregations. This allows us to look at, to bucket things into different terms that match. We can compute metrics like the count, the average, the min-max, the sum, the standard deviation, etc. We have many different ways of looking at the underlying values in those fields and figuring out metrics for them. So moving beyond the sort of basic technology and how do we provide, how does Elasticsearch provide analytics, we want to look at how do you get set up within Elasticsearch to support the use case or workload that you have. Within Elasticsearch, again, if you recall the analogy we drew at the top level, we have a cluster, but within that we have indexes. And an index is a collection of documents, as we said, that have fields and values, right? As we search, we actually break them up into a number of shards. So if we see the full document set at the bottom, we have in this case 4 shards for this index, and each portion of the full document set. A shard is a Lucene. Each shard is its own Lucene index and gets deployed to a cluster in a way that. So for this example, we have 2 different indices within a cluster. We have index 1 and index 2. And then each of those indexes has 3 shards, shard 1, 2, 3. Now, there are 2 different kinds of shards. Every shard must have a primary shard. The primary shard is responsible for writing the content for that shard when it is first up, when you send updates. And it is the recognized most up-to-date version of that shard. In addition, you can add replica shards, and those replica shards contain a copy of the primary shard. What Elasticsearch does is to make sure that primaries and replicas are deployed to a cluster on different nodes. So this provides you with a replica with the ability to do some redundancy and make sure that your data is spread across the nodes in your cluster. And Elasticsearch, again, takes care of that for you. And thinking about it, how do I figure out how big my cluster needs to be? Generally speaking, what you want to look at is I have some amount of data, and as I'm processing it and it's going into those shards, there's going to be some ratio between and the size of the resulting index from that source data. So the ratio typically is close to 1-to-1. As I'm sending in source data, if I have a terabyte of source data, typically I would have about a terabyte of index data, although 1.1-to-1 is a little bit closer to true. So if I have a terabyte of source data, I'll need a terabyte of storage online to be able to store that data. Now, adding a replica actually adds an additional copy of that data. So for my first replica, I would double the storage needed. So if I have 1 terabyte of source data, I would need 2 terabytes of storage online to be able to store that. And we can figure out our overall data node count based on the storage needed. Thinking about instance type, we have 4 instances that we support within the service. We have the T2. We feel this is best for dev and test. The M3 is a balanced node that provides you good performance across a lot of different workloads. With its additional RAM, provides you the ability to do heavier queries and aggregations. It's more slanted towards those. And finally, we have the I2 instance. This is our largest storage option. When you're thinking about sharding and how many shards should I have, you want to take the minimum number of shards that you need so that you have 50 gigs maximum in each shard. So if I have, again, in my 1 terabyte example, I would have, to set that for about 50 gigabytes, I would want to have approximately 20 shards. You always want to set at least one replica, certainly for production workloads. That additional replica, as we saw before, gives you redundancy, and if a node should drop out, you still maintain the replica of the data itself, so you can bring in a new node and it comes back, that data is maintained in the cluster. We have a couple of different types of nodes within an Elasticsearch cluster. So we talked about basically deploying to the data itself to nodes. Those are called data nodes. Data nodes hold data, respond to reads and writes for the cluster, and provide the basic search capabilities. Now, in addition to data nodes, we also have master nodes, dedicated master nodes. Within a cluster, you would always have one master node. The issue is if that master functionality is on a data node and that data node is responding to reads and writes and becomes unavailable, then the cluster will be unavailable. So you can move the functionality of the master node onto its own dedicated node. And that dedicated master node does not participate in reading, writing data, queries, anything of the kind. We always recommend using 3 dedicated master nodes for any production setting. And again, it increases the stability of the cluster. It takes the pressure off the data nodes, a little bit of pressure off the data nodes, more importantly, the pressure off the master node. And again, gives you a good deal more stability. Somewhat deeper, we want to use the bulk API, and depending on your ingest mechanism, there's a setting on the index which is refresh interval. You can set that higher for more throughput. That's one little trick. So thinking a little bit about ingest, and we can talk about sort of the services integration with the AWS ecosystem. Starting on the left of the screen, we have an EC2 instance. One of the simplest things you can do is use the Elasticsearch REST API to talk directly to the Elasticsearch cluster. With the service, we provide an endpoint where you're able simply to send Elasticsearch API calls. In addition, there's a technology called Logstash. Logstash is another open source project that provides ETL over streaming data sources. And this allows you to connect an input to that Logstash and then an output from that Logstash. And in the middle, you can do a step that allows you to rewrite, change, add information to, etc., the stream of log lines underneath. Logstash has integration with many different inputs, including some AWS inputs like Kinesis and RDS, DynamoDB, and SQS. Data can go directly there. And on the output side, we've released an Elasticsearch service plugin to do AWS SIG-v4 signing for the traffic that's going to your Elasticsearch service cluster. Now, as we saw, we also have integration with CloudWatch. So another thing you can do on the EC2 instance, you can have a CloudWatch logs agent, and that would go into CloudWatch. Along with CloudTrail, you can also send VPC flow logs, and even Amazon ECS now integrates into CloudWatch. So much the same workflow that I showed you where I sent my CloudTrail logs, I can send VPC flow logs, I can send ECS logs, and those would go to Elasticsearch service. I'm highlighting here that CloudWatch integration actually uses Lambda. Lambda is another great way to get data into the Elasticsearch service. So if you're putting data into an S3 bucket, you can trigger a Lambda function to write that data into Elasticsearch service. For other direct integration, we have integration with IoT and Kinesis Firehose, as well as CloudWatch logs. So many different ways to get data into the Elasticsearch service. Some of the technologies, and you think about the indices and how do I deploy those indexes, what's the structure I should use. A lot of those technologies will automatically do this for you, but the recommendation is to have a per time period index. So in most cases, this would be a daily index. If you have very little data in the 1 or 2 gig a day, you might want to go for a weekly index or a monthly index. If you have a lot of data, like many, hundreds of gig per day, you might want to go down to a per hour index. And then you want to shard the index, according to the data size. So again, as we said, 50 gig max per shard. If I have less than 50 gig, it's fine to have a single primary shard for that index. That will be the most efficient way to do it. If I have multiple 50 gigabyte increments, then certainly add additional shards to support that. And as we said before, we want to use master nodes to increase the cluster stability. Now, we do expose the Elasticsearch API directly. So you can access the settings for when you create your index. Again, some of the streaming technologies like CloudWatch logs do this for you, but it's important to know how to set up the sharding. Once you set the sharding on your index, you actually can't change it. So you have to do this at index creation time. And you can use this example here. So within this, I talk to my Elasticsearch service endpoint, I give it an index name, and then underscore settings. And then I can set the number of shards, number of replicas, refresh interval. There's a number of different things that I can set there. The important thing is to make sure that you lay down those settings before you start flowing data in. Otherwise, you'll just get the default number of shards, which is 5. The number of replicas setting is one that you can change dynamically. So as you're running your cluster, if you want to go from 1 to 2 replicas, you can do that dynamically by making a similar call. And it sometimes, especially if you're doing a big load-in, it's helpful to actually drop the number of replicas to 0 during the load-in, provided that you can tolerate the possibility of some data loss, and then bring it back up when you're done loading data in. Now, as we said, the Elasticsearch works as a schema-based, the fields have a particular schema that sets their types. And again, it's very important to set up the schema before you start flowing data in. Once you have a mapping established for a particular field, you can't change that mapping without reflowing the data. So the simple way to do mapping is to simply put to your index. So the endpoint there, again, is the Elasticsearch endpoint. The index is a particular index within Elasticsearch. You set the mappings, and you add a type there. That type is a stand-in for a name. We won't get into types. Typically, you would just use a single type. You don't want to use multiple types. And then you put properties. In this case, event name is a string. And the thing I would point out here, too, is that I've set this to be a not analyzed string. When working with Kibana, most of the time, you don't want your strings to be analyzed. Analyzing a string breaks it up into individual words. So thinking about something like the service names, those are like es.amazon.com. If that were an analyzed string, I would have just es, Amazon, and com going in as strings. And then when I tried to build my visualizations, I would not be able to build it as a full string. So not analyzed means don't decompose my strings into individual words, just use the full string as it is. Usually with Kibana, that's what you would want to do. We can do it actually a more automatic way. So if you're thinking about it as you're flowing data in, if you have a per time period index, or like a daily index, you don't want to have to set your mapping every single day. So Elasticsearch has a feature called templates that allows you to set up a wildcard matching mapping that will match any index that's created according to a particular wildcard expression. So in this case, I have CWL star. As CloudWatch logs is flowing data in, it's actually coming in, and all of the indexes are named CWL-date, right? So this template will match all of those indices. I can add settings here. So in particular, the number of shards is a very useful one to put in a template. That way, every index that gets created with that number of shards. And then I can set mappings. Within mappings, we're able to use what's called dynamic templates. And what I'm doing here is I'm saying match star, which is sort of toward the bottom, and then for all of those fields that match that particular type, which is anything, set it to be not analyzed. And I can also set particular fields. So in this case, under the properties there, I've set my timestamp to be a date type. So again, some of the streaming technologies, Logstash, CloudWatch Logs, actually does this for you. Firehose does not do this for you, so you have to set this up for Firehose. Depending on how you're getting data in, setting up templates is a really great idea. Makes it easy to apply a mapping. And just to make the point, Elasticsearch itself is actually a full-text search engine. So we do support sending in individual documents. This is an Elasticsearch API call that allows you to send in an individual document. In this case, it's a blog. Author is John Handler. Title is Amazon ES Launch. Here we have a bulk that allows us to send in a couple of documents, a couple more blogs, and we can actually query in a normal search engine fashion for the term ES, and we'll get the hits back for the documents that match that term. Elasticsearch, again, built on Lucene. It's a popular open source library. You can do structured and unstructured data, again, analyzed, not analyzed, being the breakdown there. You can do complex queries, Boolean queries, nested queries. You could do must not. It's a full-featured search engine under the covers, and it supports geo-search, aggregations, highlighting, suggestions, all sorts of standard search features that you would expect. And Elasticsearch is great technology. It's really quick to get set up. It's really, as you saw, it's 10 minutes to run through the setup for CloudTrail and flowing through CloudWatch logs. Very easy to get started. It can be really challenging to scale. It can be challenging to scale the ingest pipelines. And all of that is kind of undifferentiated heavy lifting. And as we looked at it, we thought, well, we'd really like to be able to do that undifferentiated heavy lifting and provide a service which would give you the Elasticsearch API and experience while we took care of keeping the lights on and doing that. So we came out with Elasticsearch Service about a year ago, and we'll just go through a couple of the highlights of that. So with Elasticsearch Service, you set up your cluster, and that is a managed cluster. We spin up nodes inside AWS. Those nodes are running Kibana and also Elasticsearch. We put load balancing in front of the nodes, and then Route 53 to provide that endpoint to you where you can interact with your Elasticsearch Service cluster. Our security is provided through IAM, and we also do some logging of metrics to CloudWatch, and of course administrative calls go to CloudTrail. Some of the nice features that we do provide a very easy way to create clusters and reconfigure those clusters. So from the console or SDK, CLI, API, CloudFormation, all of those methods, you can make a single call to create an Elasticsearch cluster. You send in an Elasticsearch version. As of now, we support 1.5 and 2.3. You send in for the data nodes, account and type of those nodes. And then for the master nodes, account and type. Type there is instance type. You set your storage. You can use either EBS storage or you can use the attached instance storage. And then we have high availability options and some couple of advanced options that let you tweak underlying parameters of the system. So with a single call, you can have an Elasticsearch cluster up and running in minutes and provided to you through an endpoint. Your interaction with that endpoint is with the Elasticsearch API. It's a straight up drop-in replacement for an existing Elasticsearch cluster. And indeed, you can actually then, with a single call, change the configuration of that cluster so that all of these parameters here, the version, well, sorry, not the version, but the data node count or the master node count, storage options, instance types. With a single call, you can say, hey, I'm running on 3 M3 mediums with instance storage. I want to run on 4 R3 extra larges with EBS storage of 512 gig. Single call, we behind the scenes seamlessly bring in new nodes and swap that cluster over behind the endpoint, and it's up and running for you. So makes it really easy to not only to deploy but also to maintain your cluster and to grow it when you need to. We provide a high availability option called Zone Awareness. Zone Awareness splits your cluster's nodes into 2 separate AWS availability zones, and each of those zones then gets half of the clusters, and then we route the primary and replica shards into those different zones. So what you can see here, we have a balance where the primary for green 1 is in availability zone and the replica for green 1 is in availability zone 2. The 4 nodes are split into 2 different zones. Should an entire zone go out, you would then have still the other zone up and running with a full copy of the data. As I said, we expose a number of metrics through CloudWatch. This is just a short list of some of the important ones that you would want to monitor. So we have free storage space. Of course, if you're running out of storage space, you'll want to make that cluster configuration change API call to add more nodes to the cluster to get more storage or increase your EBS size. For CPU utilization, you want to make sure that your cluster is not running consistently above 80%. If that's the case, then probably you need to scale up, either in terms of instance size or number of nodes. Similarly with JVM memory pressure, JVM memory pressure gives a single number that lets you know how much of the JVM heap is being used. If that breaches 80%, you're in trouble. If it breaches 90%, typically we see those domains or clusters would eventually fall over. So you want to make sure that your JVM memory pressure is bounded by about 80%. And the solution there, if it starts to be consistently above that, is to move up in instance size to add more RAM to the picture. We have a cluster status, red, yellow, green. That you should definitely monitor for yellow or red. Some replica shard is not currently allocated to any node. This can happen if you have only a single node in your Elasticsearch service domain, and you have a replica. That replica can't be allocated anywhere because it can't go on the same node as the primary, and there is no other node. So that's a common problem that we've seen people run into quite a bit. Last one to take a look at is the master CPU utilization. This is just looking at CPU on the master nodes. You want to, again, monitor and make sure that your master nodes are not running at capacity. If the master goes out, you would lose access to the cluster. Our security is provided through Identity and Access Management. You can write a policy statement basically in 2 different ways. There's an IP-based strategy where you select particular IPs and you allow or deny access to different calls for those. Or there's a user-based strategy where you select a principal and then you send SIGV4 signed requests. In this example, we just see here, this is a user-based policy for Susan. The action is, again, we have the HTTP actions. These are the actions where you would be talking to the Elasticsearch API. As well, we have the administrative actions like create Elasticsearch domain, list domain names. You can mix and match. You can provide different access control for different users that way. And on the resource, it's the particular domain that this policy applies to. This could be either at the domain level or it can be indeed at the index level. So you have the ability at a fine-grained control level to be able to say, okay, Susan can access this particular index for ES HTTP GET, etc. Within the service, we have 2 components of cost. The first component is the compute. So as you're deploying instances, we charge based on the instance types that you've deployed for your data and master nodes. And then if you choose to use EBS, we charge based on your EBS usage. We do, of course, normal AWS data transfer charges also apply. And if you are qualifying for the AWS free tier, we do also provide access to T2s within the free tier. So looking back and just summing up, we had a look at a demo that showed some of the capabilities of Elasticsearch and Kibana to take log lines underlying and provide you with visualizations, metrics, other ways of pulling out information from that sort of undifferentiated stream of log lines. And Elasticsearch itself is the underlying technology that allows you to do it. It's a search engine that is based on Lucene. Lucene itself just reads and writes search indexes. A lot of what Elasticsearch does is on top of that. The aggregation is the fundamental analytical capability, if you will, for Elasticsearch, and it allows you to split into buckets and compute metrics on those buckets. The Elasticsearch service makes it easy to get started and easy to scale and grow as you manage your Elasticsearch cluster on AWS. So that is what we have for prepared material. We're going to go ahead and go into QA now.
So thank you, John, for the great presentation, and Carl for engaging our audience throughout the presentation. On your screen, you'll find the live polls on the left-hand side. Please provide us with your feedback by clicking the radio button next to your reply for each poll. We have about 8 minutes now left in our session, so please feel free to continue submitting questions. We'll start addressing some of those that have been submitted. We do apologize in advance if we might not get to them all today.
Okay, thank you. So just looking down the list here. So are the CloudTrail logs searchable by EC2 instance tags? I don't actually remember whether the tag itself comes out into the CloudTrail log. I haven't seen them though, so I'm guessing that they are not. Okay, so can Elasticsearch search all S3 logs stored in different regions? So I think this is in the context of the demo. What the demo does is CloudTrail is dumping objects to a particular S3 bucket, and then those are flowing into CloudWatch logs. If the more general question is, if I have some logs that are already in S3, and can I search those? The answer is definitely yes. You would want to use Lambda for new logs coming in, and then potentially you would have a process that would dump all of the logs that are already in S3 into something like Kinesis or SQS that would queue them up, and then you could write them to Elasticsearch on the other end of that queue. So question, can we use ClickSense or Tableau instead of Kibana? I am not aware, but I don't believe that Tableau would run on top of Elasticsearch. And as much as I know, ClickSense would also not run on top of Elasticsearch. So Elasticsearch and Kibana are sort of a paired technology. Kibana itself relies on the aggregations feature of Elasticsearch to provide the visualization, but those technologies kind of go together, and I'm not aware of another technology that does visualization on top of Elasticsearch. Actually, there is one called Grafana as well. But again, they're specialized. It's not just a generalized BI tool. And when I think about it, when I think about Elasticsearch and what does it do, Elasticsearch itself is very much slanted towards a tactical, just-in-time kind of either diagnostic or figuring out, monitoring and debugging of a current issue. I think of typical BI software as being more slanted to a longer-term view of what's going on that's more predictive in nature than tactical or deductive, if you will. So question, can we easily truncate the Elasticsearch index to only keep the last 30 days of data? So when I was talking about the index per day and sort of the strategy for managing the flowing logs, one of the reasons to do index per day is that you can then, at the end of that retention period, so let's say I want to keep 1 week or 2 weeks of data, I'm flowing in today's data, and then I can delete out the 15th day ago's data, right? So it's very easy with a single command to delete an index. And this is the recommended way to do these per time period indices, is to be flowing data into today's index, and then at the end of the retention period to delete off the oldest index. There is a TTL feature within Elasticsearch, but we don't recommend, and Elastic does not recommend, using that feature. It's being deprecated and will soon be rewritten, we hear. But the best way to do it is through deleting entire indices. And you can set up a little, triggered Lambda function or cron job or something like that. It's a single command line to delete out an old index. A question about the number of master nodes. So why do we recommend 3 master nodes? Well, so as I said, the cluster always has a master node. And that master node is elected based on a quorum of how many nodes are in the cluster. And what that means is if I should have a network split and I have an even number of masters, right, then each of the halves, let's say I have 2 master nodes in my cluster, and each splits into one of the network splits, then that means that each of those halves of the cluster can actually elect a master node and decide that it is a cluster. And in that case, you would have data being written only to one or the other of those partitions. And that would mean that ultimately you would lose data. So by providing an odd number of nodes, you ensure that only one of the 2 halves in a split could ever elect a master node and decide to be a cluster, right? So if I have 3, then I have a 1 or a 2, and it requires 2 to elect a master node, then that's only the half that has 2 can do that. So odd number for sure, and then 1, if you have 1 master node and that node becomes unavailable, then your whole cluster is unavailable. So that's not enough redundancy to provide a lot of stability. So the recommendation is for 3, because 3 is sort of the minimum number, but it's an odd number. That's how we get to that recommendation of 3 nodes. We have about 1 minute left. I'm going to take one more question here. You guys are asking hard questions. I'm looking for an easy question. Is RES version supported by top beats, packet beat, and file beat? So yes, you can connect those beats to Elasticsearch service. There's a sort of tricky security and access control question there, right? So to the best of my knowledge right now, I don't know of sort of outputs that do SIG-V4 signing for those requests. So that means you'd have to write an access policy that was based on the IP address. If your packet beat, file beat, whatever, is at a known IP address, then yes, you can write an easy access policy that allows you to send from those IPs. Otherwise, you would do something like a reverse proxy in front of your cluster at a known IP address and then have those guys connect to that. Well, that is all the time we have today. Again, I thank you so much for your attendance and attention. Turn it over to Jerry.
Thank you. I want to extend a special thank you over to John today for the presentation. Thanks for your efforts today. And Carl, thanks for answering the audience's questions in the Q&A. If you have any comments on our previous webinars or any upcoming webinars, or suggestions on topics that you wish AWS to cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us improve webinar programming.